So greetings to all of you. My name is Lavlesh here to present a PPT on topic recurrent neural network, which is also known as RNN, mm, guided by Miss Shushma Khatri ma'am. So let us start with the definition of a RNN. So the artificial neural network adapt to work for time series data or data that's involves sequence. Okay, so that uses a hidden layer that recommends specific information about the sequence which is known as RNA. RNA has a memory that stores all the information about the calculation, and the RNA is formed from forward network. As you can see in this diagram, that input layer and hidden layer and output layer, which implies to a recurrent neural network, which have um 2 points. So next thing we goes up with some more key features of the RNN that includes uses the same weights for each elements of the sequence, as you can see in the diagram. Need to inform about the previous input before evaluating the result. Third one is comparing that result to be expected. Well, expected value will give us an error, and fourth is propagating the error back through the same path will adjust the variable. So these are all points can be explained through the diagram. So hence we move further for our presentation. So let's go. Why recurrent network? Why recurrent neural network? So the basis of the recurrent neural network is that the RNN one created because there were a few issues in feed forwarding neural network. As we can uh, as we can remember that feed forwarding neural network have more disadvantages and compare so to eradicate those shortcomings, we introduce the RNN. RN. The special so why we use RN that so that uh, cannot handle sequential data. Consider only the consider only the current input. mm, Cannot memorize previous input. Loss of neighborhood information. It does not have any loops or circle. These are the major key points or advantages or uh, because of which we use the recurrent neural network. So as you can see in this diagram, which clearly explains that the input and hidden layer and output layer, the hidden layer is between the input layer and output layer, and feed for and simplified representation is given here, like input layer, hidden layer, and output layer. So let us move further. So let us explain the architecture of RNN, which consists of output, hidden layer, input, output with respect to time, which implies that the hidden layer, uh, which have the two hidden layer and activation function. Here x is the input vector with respect to time. Y is a predicted output. O is initialized value at the time of 0. O1 is output at the time of 1. O2 is output at time of 2, and T is represents the time, and W is weight. So here is the architecture of neural network, which consists of activation function through through which we apply the weights and biases to return a output, which is denoted by y, and it is taken considered at a different time, which are t1 t2, and this is the basic architecture of RNN. So let us move further with networks neural uh, recurrent of types. So types of neural networks, recurrent neural networks, as we can see uh, in this in this slide, that there are three types of four types of recurrent neural network: one to one, one to many, many to one, many to many. So one to one have single output, single input, and between it have only one hidden layer. Second one is one to many. One to many have multiple outputs and single input, in which in between which we can implement as many hidden layer as we can. So fourth is the many to many recurrent network, neural recurrent network, recurrent neural network. So in which we have single output and multiple inputs, and we can implement as uh, multiple designs, we can implement multiple hidden layer between it. And last is the many to many uh, recurrent neural network, which have multiple output and multiple input, and which we can include multiple hidden layer between it. So one to one is also known as machine learning promise, uh, used for general machine learning problems. One to many is used for image caption. Many to one is used for sentiment analysis, and many used for machine translation. So these are the application of the types of neural network, which can be easily used in day-to-day life for helping uh, in our artificial intelligence and machine learning. So let us move forward with steps to train the RNN. So this is the very important topic we are going to discuss here. So the first steps goes like this. The initial input is sent with the same weight and the activation function. This concludes that the initial input is sent with the same weight. It must not be it must not be different, because it can give the chances of error. The current the current state calculated by using the current input and previous state output. So it is a second step which states that the current state calculated by using the current input and previous output must be calculated. Uh, so third step goes like this: current state xt becomes xt minus 1 for second time step. So as we can see in the diagram that automatically, for the second round, the xt becomes the xt minus 1 for the recurrent RNN. So fourth step is keep on repeating for all the steps. So keep on repeating all the steps. So we have to again repeat all the step uh, until we get the output. The fifth step goes like this: the final step calculated by current state of final state and all other previous step. So here we are represent we are stating that the final step calculated by current step uh, of final state of all previous steps. Uh, Sixth step goes like this: as an error is generated by calculating the difference between the actual output and generated output by RN model. So this is a step regarding the error finding and error detection. So the last step goes like this: the final step is where the process of backpropagation occurs. So as you can see in this diagram also, so here we can explain the recurrence formula: st equals to fw st minus 1 comma xt, where st is a new hidden state, fw is a some function of parameter w, ht minus 1 is the old state, and xt is the input vector at some time spent. So this is the step for training RNN. So now the important important aspect of a RNN, important part of an RNN, and that we have studied in steps, that is back propagation. So these are so this is the some information about back propagation. To reduce the loss function derivative of yi uh, by chaining by chain rule, wxh is independent of yi. So these are the technical terms which explain the back propagation, first, the first step goes to reduce the loss function. Second step goes for weight updation. Third step goes for weight updation in backward propagation, and last one is goes for by chain rule. O4 is dependent on W, where loss function is reduced, as you can properly see in this diagram. So let us move for the let us move forward for the our next slide, which states that, so so this is the actual these are the peculiar and most important applications of the uh, RNN, or a neural network, recurrent neural network. Applications are, applications are machine translation. So as we can all see that, all know that are used for machine translation, by which the code are encrypted, and codes are encrypted, or languages are translated from one form to another. So second step is text classification. Text classification or sentimental analysis. When the RNN is applied on a data set um, of sentimental analysis, is provide a result in the three state: negative, neutral, positive, which helps to understand the classification of the data set on the basis of sentiments. Third applications is captioning image. As the picture suggests that, when a picture is given, so the RNN will automatically caption it like a dog is standing in the ocean, like this. We can do this by the help of RNN, recurrent neural network. And last is the recognition of speech. So as you can all know that, we can recognize the speech by the help of RNN, and these are the primary examples and applications of the RNN, which are used in daily life, to make in a field of artificial intelligence, to make our life easy. So let us move forward with our next slide. So now we discuss the advantages and disadvantages of the RNN. So advantages goes like this: input of the any length, it have input of any length. Disadvantages: computation is slow. Uh, second advantage is to remember each information through the time, which is very helpful in any time series predictor. Third advantage is even if the input size is larger, the model size does not increase. Fourth advantage is weight shared across the time step. Now second disadvantages goes like this. Training can be difficult. Third disadvantage is using of a ReLU and TANH as an activation function can be very difficult to process sequence that are very long. And fourth disadvantage is prone to problems such as exploding and gradient vanishing. So here we conclude my PPT. So thank you to all the viewers and listeners. Uh, you can reach out to me by the help of comment section, and I will provide you an answer for it. So thank you. Thank you to all of you.